Hello students, welcome. A piece of wire is bent in a shape of parabola y is equal to x square, y axis is in vertical, with a bead of mass m on it. So obviously it is a frictionless is given, and if you keep one bead in y is equal to x square shape wire, so what will happen to bead all the way come down and will be in a equilibrium position. So here this is a equilibrium position, this is in rest, summation of forces is 0. Now what they are telling is that the condition is given in a question is, now if we accelerate with the x-axis, so we are accelerating with the x-axis a the entire system, so what you will expect, so it's a Newton's second law, like it's like pseudo force will act, right? So here after acting pseudo force, what will be new position of bead? Initially the bead is here, so the new position of the bead is somewhere here, right? So here if the bead is there, it is in equilibrium. What they're asking is that, read the question again, the distance of the new equilibrium position they are asking from y axis. So what they're asking is that this particular distance, so which means that from y axis they are asking means we have to find out x distance from origin. So I have to find out new position, equilibrium position. So what you will expect here when this is in equilibrium, because of acceleration here the force will act, Newton's second law and as well as laws of Newton's laws of motion. So here it will act, the force will act, the pseudo force will act in opposite direction. It is something like this, right? So in this direction, so ma. Okay, so what will be the other forces? So assume that here some angle theta it's making, if this is angle theta is making, and you just see that there will be a normal force, okay, n, and this is pseudo force. If there is a n, so free body diagram draw, and I have n, this is angle theta, so and here n, and this is n cos theta, and here n sin theta, and here just see that this n sin theta is balanced by ma, that is pseudo force that is causing the shift of new equilibrium position, and n cos theta is balanced by, so here mg, downward force, right? So now we can write that n cos theta is equal to mg vertically, horizontally n sin theta is equal to ma. So let us take it as equation number 1. Equation number 2, divide both the equation. So what I'll have is that tan theta is equal to a by g, right? So this is one relation we are getting. Let us take it as equation number 3. What they're asking is that new position shift of equilibrium. Now you just see that this is angle theta, right? So we know that it is changing at every point, it is changing. So from kinematics we know the basic relation that the rate of change of y axis with respect to x, that is a slope, that is tan theta is equal to a by, here a by g, but we know by using x and y, so can I write that dy by dx? So tan theta is equal to y by x. For a small change we can write as dy by dx. So now what is given as a equation? So they gave as a equation y is equal to, if I differentiate this, y is equal to like dy by dx, so y is equal to kx square. If I differentiate this, what I'll have, k is constant, a differentiation of x square 2 times x. So now what I have is that tan theta is equal to k 2x. So equation number, let's say 4. So what they're asking is that they're asking what is the x, so just equate 3 and 4. So by equating 3 and 4, equate 3 and 4, so what will have, a by g, or else k 2x is equal to a by g, or I will write it as x is equal to, because what they're asking is that, read the question, find the new equilibrium position from y axis. So which means what they're asking is that x. So now I'll substitute here, just rearrange this. So a divided by 2 k g, right? So this is a position. And note this point here, what we are doing is that this particular one is nothing but the inclined plane. Just take in laws of motion there is an inclined plane theta. If I give some acceleration a, the block will stick together with the inclined plane. For that condition is, do you remember, tan theta is equal to a by g. So we are using that, and kinematics, basis of kinematics, we are doing this particular problem. This is right answer.